Today we'll discuss a problem called lowest common ancestor of a binary tree. That is the problem number 236 of LeetCode, and the complexity is medium. So basically, what is the lowest common ancestor? This lowest common ancestor of the two nodes is the lowest node in the tree, that is for which both the node are descendants. Like if you see this tree here, 5 and 1s are two nodes and they both are descendants of the 3. So this 3 is lowest common ancestor here, and similarly for 6 and 2, they are the descendants of 3 and 5, but the lowest here is the nearest one is the 5. So here we will solve this problem in that lowest common ancestor of a binary tree using recursion. So basically, recursion, we need to define some base cases, and also you can say that optional checks, that like I am checking this in the guard statement, guard let root node equal to root, else we will return nil. And then we will check the p node, guard let p node is equals to p, else return nil, and guard let q node is equal to q, else return nil. And if in that cases that if the root node is same is any one of the node, in that case you will say their lowest common ancestor is that root node. Like if root node dot value is equals to p node dot value, because here we are checking the value because there is a condition that node values are unique and p are not equal to q, and p and q will exist in the tree. So we can check with their value, p node dot val or root node dot value is equals to q node dot value. In that case our root node will be their lowest common ancestor. So we'll return root node, and let's say this condition also not passed. So then we will calculate the left LCA. So basically this is the left LCA, that lowest common ancestors, and we will pass their root node dot that left subtree. We are moving to the left subtree. That yeah, root node is not my ancestor, so I will check the left root node, then p node and q node, and also we will check the right side of the tree, right LCA we will check that lowest common ancestors is JS right, p node and q node. Now let's say we have to calculate the left LCA and the right LCA. Now if in the both cases let's say our both are not null, but what we are returning the left LCA and right LCA. Okay, so both are not null. Not equal to nil, and right LCA not equal to nil. In this means that my both of the nodes are exist into different part of the tree. Means let's say it is 6 or 8. So 6 will be my left subtree and exist in the left subtree, and 8 is exist in the right subtree. How? Because if we do a dry run, so if we continue with that, once when it will traverse the tree at a certain point, that we will reach 6 and it will match with the 6 and return the 6 as the root node and 8 as the LCA. That means that they exist in the different part of the tree. So in that case, my root node is their lowest common ancestor. So I will return root node as the answer. Else, if one of them is null, so in that case, that means let's say 6 and 2. Okay, so in that case, that 5 will be their LCA. So if anyhow both the nodes are exist in one part of the tree, means that is exist in the left half, means exist in the that half, their LCA. So here 5 will be the LCA, or for 0 and 8 their LCA will be 1. So as I from this my calculation, you see that if both of the nodes are exist in one particular part of the tree, that means that LCA is my lowest common ancestor. So how we can do that? Using nil coalescing operator, we can do that either of them, if left LCA is not nil, so left LCA will be the answer. If left LCA is the nil, then both the nodes exist in the right side of the tree, so right LCA will be the answer. Now I will run the code. Yeah, it's accepted. I will submit the code. Yeah, it's passed. But it is 96.02% and 52.46%. Okay. So if you like this video, please if you like this video, so please tap the like button and also subscribe my channel for further videos. Okay, thank you for watching this.